this video, we're going to be looking at solving nonlinear systems algebraically. In this video, we're going to be looking at a quadratic / linear system. So number one, I want to solve this system. I have y equals x squared minus 6x plus 3 and y equals negative 2x plus 3. And I want to solve this. So first I see that they're both equal to y. So that means that these two are also equal to one another. So to set this up, I can say that x squared minus 6x plus 3 is equal to negative 2x plus 3. And now I can solve this for x. So I'm going to get my x values. But if you recall from the previous video when we're solving it with graphs, my solutions are ordered pairs. And so when we find our x values, we're going to have to plug it in to find our corresponding y values so that we can get those points. But we'll get to that. First, I want to solve this quadratic. I know for any quadratic, I want it to be in standard form. So I need all of my terms on one side. So I'm going to add 2x and subtract 3 from both sides. So when I do that, I get x squared, negative 6x plus 2x, I get negative 4x. 3 minus 3 is just 0, so I end up with x squared minus 4x is equal to 0. Here I see I only have two terms, and I do have a GCF. They both share an x, so I'm going to factor out the GCF. And when I do that, I'm left with x minus 4 is equal to 0. And now I can use the zero product property to get my two values of x. This tells me that either x equals 0 or x minus 4 equals 0. And then when I add 4 to both sides, get that x is equal to 4. So I have my two x values. Now I need to find my corresponding y values so I can get my ordered pairs. I'm going to start with x equals 0 and plug that into either of these equations. It doesn't matter which one we do. It's a little bit easier to work with your linear one, so I'm going to plug it into that one. And so when I do that, I have y equals negative 2 times x, which is 0, plus 3. Or in other words, that y equals 3. So that means that my ordered pair for this one is 0, 3. And then I'm going to plug in x equals 4 into this same equation and find the corresponding y value in x equals 4. And so when I do that, I have y equals negative 2 times 4 plus 3. Negative 2 times 4, I get negative 8 plus 3. So y is equal to negative 5. So that means that my corresponding point here is 4, negative 5. So my two answers are 0, 3, and 4, negative 5. And you can always check your work by plugging it back in. So if I were to plug in 0 into my top equation, I'd get 3. And if I plugged in 4 here, I get 16 minus 24, which is negative 8. Negative 8 plus 3, I get negative 5. And so it checks out. Okay, let's look at another example. Here I have y equals x squared plus 2x plus 4 and y equals x plus 10. I see they're both equal to y, so I can go ahead and set these equal to each other. And so I have x squared plus 2x plus 4 is equal to x plus 10. I want this to be in standard form to be able to solve it. So I'm going to subtract x and subtract 10 from both sides. So when I do that, I get x squared plus x minus 6 is equal to 0. And now I'm going to go ahead and solve this quadratic. We've learned several different methods to go ahead and solve this. I always like to start with factoring to see if it works. Or if you're more comfortable with the quadratic formula, you can go straight to the quadratic formula as well. I'm going to go ahead and use factoring and see if this can be factored. So I'm looking for two numbers that multiply to negative 6 and then add to equal 1. So multiplying to negative numbers, so one number needs to be positive, the other needs to be negative. It's adding to a positive number, so my smaller number needs to be negative. So I have negative 1 and 6, negative 2 and 3. And so I see that negative 2 plus 3 equals 1. And so I have x minus 2 times x plus 3 is equal to 0. And solving that, I have x minus 2 equals 0, x plus 3 equals 0. So I have that x equals 2, and x equals negative 3. However, I'm not done yet because I know I need ordered pairs, so I need to find my corresponding y values. So I'm going to first find my point that corresponds with x equals 2. Again, you can use either of these equations. I'm going to use the bottom one just because it's a little bit easier to plug in. And so when I do that, I have y equals 2 plus 10. So in other words, y is equal to 12. When I plug in x equals negative 3, I get y is equal to negative 3 plus 10, or y is equal to 7. And so my 2 points from this first one, I get 2, 12. And then from this second, I get negative 3, 7.